Hello, everyone. Welcome to Professor Messer's CompTIA A+ 220-1201 and 220-1202 training course. This training course is
With a great idea, you just want to get things down on paper. Grammarly is the second set of eyes that helps me get work done. My name is Claudia. I'm a marketing manager and adjunct professor. Grammarly.
During this video, we're going to look at a number of different settings inside of our system BIOS. If you'd like to look at your own BIOS, you can launch it when the system starts up. Usually there is a function key or special key you push on your keyboard as your system is booting. And if your system recognizes that you've pushed that key, it will launch the BIOS setup program. Very commonly, this key is the delete key, an F1 key, an F2 key, or it might be a combination of keystrokes such as Control S or Control Alt S. Some desktop hypervisors also allow you to stop the VM from booting to go into the BIOS settings for that virtual machine. If you're in Windows 10 or Windows 11, you can use Hyper-V for this, or you can use third-party hypervisors such as VMware Workstation. If you're running Mac OS, you could run VMware Fusion. And if you'd like to download either of those, you can go directly to the VMware website, or you can use our link at professormesser.link/VMware to also go to that page. Unfortunately, if you're using VirtualBox as your hypervisor, it does not support this virtual BIOS configuration, so you may want to use a hypervisor that does provide that functionality, or you may want to use an actual physical computer. And a solution that doesn't use any hypervisor or physical computer is to find a simulator of a BIOS online. There are many available. Simply search for UEFI BIOS Simulator, and you'll have many options to choose from. If you're running Windows 10 and Windows 11, you may notice that when you start your computer, you don't receive any prompts to push any special keys to start a BIOS. That's because these versions of Windows don't actually power all the way down when you turn your computer off. This is because they use a feature known as fast startup. This means that your system only partially shuts down so that when you turn it back on, it can start up that much faster. Unfortunately, this also means that it does not start the BIOS setup process, so there's no opportunity to press the key and enter the BIOS configuration. If you'd like to tell Windows to shut down completely so that you can then start this BIOS configuration, you can hold down the Shift key when clicking Restart, or you can choose Settings, Update and Security, Recovery, Advanced Startup, and Restart Now. You can also make temporary changes to this inside of the msconfig utility, that is the system configuration utility in Windows. And if none of these options are available to you, one way that you can prevent fast startup from working is to interrupt the boot process 3 times in a row. And if you do that, the 4th time through the boot process will begin from the very beginning. This may not be obvious when you're restarting Windows, but if you're someone who does need to make a BIOS change on a production system, you may find that you have to restart the system at least 3 times before you even have the option. Before we get into the configurations of the BIOS, let me warn you that making a change to a BIOS could result in a system not booting or not being stable. For that reason, we recommend that if you're making any changes to your BIOS configuration, that you document all of the changes that you made. One very easy way is to simply write down what the change might be, or if you have your phone with you, you might want to take a picture of the screen before you make that change. It's also a good idea to have an understanding of exactly what you're changing in the BIOS. Most of the settings are relatively straightforward, but there are some configurations dealing with memory and CPU that may be difficult to understand. So it's important that you don't randomly make changes to these configurations because it could cause problems with either the startup process or the ongoing reliability of the system. And as many of you know, I'm a big proponent of backups, so if you are planning to make any changes to your BIOS, make sure that you have a backup of that configuration that you can always revert to. The BIOS is some of the first software that runs on your computer. When you hit the power button, the BIOS will take over and look at all of the configuration settings that you've made for this device. For example, you can disable hardware inside of the BIOS, and when you load your operating system, you'll see that the operating system has no idea that that hardware exists. That's because the BIOS is that connection to the hardware, and if we disable that connection, your operating system has no idea how to access that hardware. The BIOS is also where you configure the boot order for your system. There are a lot of different ways that you could boot your system, and you probably have a number of different storage devices that you could boot from. You might have multiple SSDs inside of your system. You might have USB connections that you can plug in, and any one of those could be used as a boot device. You have to configure your BIOS to tell it which device it will try to boot from first, and if there's no operating system on that drive, which one you'll boot from second. If there's no operating system on that drive, which you'll boot from third, and so on. I'm using an emulated BIOS to demonstrate some of these capabilities, so if you see a number of unusual settings such as an invalid serial number or a MAC address of all X's, you'll know why. Let's look at the boot configuration on this particular system. We'll go to the option in our menu called Startup, and in our Startup system, the very first option is the primary boot sequence, which determines what sequence will be used when the system starts up. You can see there are a number of different drives inside of this virtual system. There's a number of SATA drives, there's an M.2 drive, you've got a network connection and USB drives, and you can use any of these as the boot sequence. The BIOS allows us to select any of these available drives and move it up or down in this list to determine where it sits in the drives, and you can use any of overall boot sequence. For example, if you have a USB drive that you'd like to boot from, you'll need to move that up to the very top so that it's one of the first drives accessed during the boot process. Or perhaps you've installed a new M.2 drive and you may need to move that up higher in the sequence so that it becomes the first drive accessed during the boot process. We mentioned earlier that the BIOS allows you to enable and disable different hardware, and a good example of that is the USB connections that you have on your computer. Those USB drives allow us to plug in storage devices, in some cases very large capacity storage devices, and some organizations have security teams that would like to restrict access to those USB storage devices. This creates a bit of a balancing act, of course, because those USB drives are very convenient and very fast, especially if you need to move information from one system to another. Unfortunately, there have been cases where a USB drive could be used to cause problems on a network. A good example of this is in 2008 when the United States Department of Defense banned all USB flash drives on all of their systems, and it extended this ban for 15 months. That's because someone brought in a USB drive, plugged it into a Department of Defense computer, and it infected itself with the silly FDC worm, which then infected all of the other systems in the Department of Defense network. For that reason, the system administrators at the Department of Defense went into the BIOS of their systems and disabled the USB drives.
This may be the last ad you ever see. Because with the free AdBlock extension from
in our BIOS, the USB configuration is under Devices, and it's the option that says USB Setup. In here, you can enable or disable interfaces, change what type of support you're enabling for those devices, change which exact port is enabled and which one is disabled, and make a number of different configuration options to the USB settings. Many of our computers have cooling systems inside, primarily because it can get very warm inside of that computer case. The CPU puts off a lot of heat, and we need some way to get that heat out of your system and bring cool air in. Commonly, this is done with fans. We'll often have fans right on top of our CPUs to cool them directly. We might also have fans on our case that is pulling cool air through the entire computer to not only cool the CPU, but everything else inside of that case. Most motherboards have temperature sensors and integrated fan controllers on the motherboard itself, and those fan controllers are configured inside of your system BIOS. This allows your motherboard to constantly monitor the temperatures, and if it starts getting warm, it can spin those fans up a little bit faster to help cool off the entire system. You'll notice on most modern motherboards that your fans are connecting directly to the motherboard itself so that it can provide that cooling function. You'll notice this one is plugged in. It's even marked CPU Fan 1. In our BIOS, the fan controls are located under the power option, and it's down under intelligent cooling. This computer supports a number of different cooling options. One is a best performance, which means it will run at the best possible cooling for that system. A best experience, which means it will minimize the amount of noise being made by the fans. And then a full speed, where all fans in the system are always running at full speed. If your fan is running in a place that's relatively quiet, you may want to use best experience. But if you're in a data center, you might want to choose full speed. You can decide which option is best for you by making that change inside of your BIOS. Most of us probably have some type of antivirus or anti-malware that runs inside of our operating system. But we also need to protect against malware that could load into your system before the operating system starts. One way to prevent any malware from starting up before your operating system or even overriding your BIOS itself is to use a feature known as Secure Boot. This is a new feature that was added with the UEFI specification, and you won't find this inside of a legacy BIOS system. Secure Boot has a digital signature for every well-known operating system that you might use. This means that it knows what the operating system should look like, and if malware makes any modification to that software, it will stop the boot process and prevent that malware from running. So if you're trying to run a very old operating system on your computer, you may find that the Secure Boot feature doesn't allow that operating system to run because it doesn't have a digital signature for that particular software. In that case, you may need to disable Secure Boot so that you can start up that older software. When you want to run the newer software, you'll want to re-enable Secure Boot so that it will work properly with the modern operating system. Secure Boot checks not only the operating system that you're running, but the BIOS itself. When you start your computer, the Secure Boot process looks at the BIOS configuration and determines what the manufacturer's public key is for that particular system. Secure Boot is not only protecting the operating system that you're running, it also protects anyone from overriding your BIOS. It does this by checking the public key for the manufacturer of your system, and it compares that with a digital signature on the BIOS update that you're trying to install. If it notices that the digital signature cannot be confirmed with the public key, it will prevent any BIOS update from overriding the current configuration. Secure Boot also checks the bootloader that runs before your operating system starts. It does this by looking at the digital signature associated with the bootloader and compares that to a trusted certificate on your system. If Secure Boot cannot confirm that your digital signature is valid, it will not start the operating system. On our computer, the Secure Boot options are under Security. We'll have to scroll down to find the Secure Boot options, and then we'll choose the option for Secure Boot. Inside of this configuration are options to enable or disable Secure Boot, and then to manage the keys that are used to confirm those digital signatures. There are also a number of security features inside the BIOS that can either prevent the system from booting or prevent the system configuration from being changed. This is all done through password management in the BIOS itself. If you'd like to prevent anyone from booting the system unless they have the right password, then you'll want to enable a boot password. You'll sometimes see this referred to as a user password. When your system starts up, it will prompt you for a password, and you must enter the password for that system to boot an operating system. This obviously will work regardless of what operating system you happen to be running on that computer. As a system administrator, you may want to make configuration changes to your system and prevent anyone from undoing those changes that you've made. A good example of this is you may have disabled the USB connections on your computer for security reasons, and you don't want someone to change that configuration and re-enable those USB connections. To be able to prevent this change, we would configure a supervisor password. You might also see this referred to as a BIOS password. This restricts anyone from starting the BIOS configuration unless they have the correct password. Both of these passwords are obviously important to remember. If you don't have the boot password, you can't start the computer. And if you don't have the supervisor password, you can't make any changes to the BIOS. If you do find yourself without one of these passwords, then you'll need to reset the BIOS configuration completely. You'll want to check your motherboard manufacturer to determine what process is used to reset the BIOS for your system. In our BIOS, those passwords are set in the security settings. We were already in the security settings when we were looking at the Secure Boot options. So we'll back out of this, and if we scroll all the way to the top, you can see there are options for a supervisor password, a power on password, and this system also supports other passwords as well. Our BIOS software and the BIOS configuration settings are both stored on the motherboard. The BIOS software itself, what we sometimes refer to as the firmware, is stored in flash memory that is on the motherboard, and it's flash memory so that we can upgrade that BIOS if we need to. The BIOS configuration settings are often stored in separate flash memory that is also on the motherboard. When working with the BIOS, you may run across references to CMOS. This is a complementary metal oxide semiconductor. This is a type of memory that we used to use when we were working with the BIOS, but these days most BIOS configurations are simply flash memory. Before the advent of flash memory, most of these configurations were stored in volatile memory on the motherboard itself, and all of those configurations were kept active with a battery that is on the motherboard. These days, those BIOS configurations are stored in non-volatile flash memory on the motherboard, so they don't need a battery backup or any type of power source to maintain that configuration. For that reason, if you need to reset the BIOS configuration, simply removing the battery is not going to do it. You very commonly use a reset process that needs physical access to the motherboard. You add a jumper to the motherboard, turn the computer back on, and it resets the BIOS. For example, we have an Asus motherboard here. This is a Micro ATX motherboard. And if you look very closely near the bottom of this motherboard, you'll see a small chip. That's the BIOS chip that is used to store the BIOS firmware. This motherboard allows you to reset the BIOS configuration using a jumper that's located just to the right of the BIOS chip itself. And you'll notice that it's marked CLRTC. On this motherboard, that stands for Clear Real-Time Clock RAM. We want to use a jumper on those two pins to be able to short that connection and turn the computer on to reset the BIOS config. This is what the pins look like on the motherboard. You can see it's just a couple of copper pins sticking out of the motherboard, and we want to connect those pins together. To do that, we use a jumper.
Monday CRM has the best AI features in the game,
especially in sales.
hands down.
So for me, email.
It is one of these little plastic squares, and inside of this plastic square is a piece of metal that connects those two copper connections together. If you look closely at this image, you can see the bar going straight across, and if you push this jumper down onto those two pins, it connects those two copper pins together, and you've shorted the connection. There are a remarkable number of temperature sensors on your motherboard. You'll have sensors inside of your CPU, inside of the memory, and inside of other components that are on the motherboard itself. For that reason, most BIOS configurations have an option for temperature monitoring, so you can start up the BIOS software to see what temperatures this system might be seeing. You can certainly use third-party software to be able to view these temperatures, but most BIOS software will also allow you to view that temperature information within the BIOS configuration itself. This allows you to monitor the temperature inside the hardware of the computer itself without bringing in any other operating systems or other third-party software. These temperature settings may be in a central monitoring tool, or it may be added to the hardware monitoring that you have on the system. For example, on this computer, the CPU itself is currently showing a 45 degrees centigrade temperature. So if you've installed some new hardware and you want to be sure the system is cooling everything properly, you may want to look inside of your BIOS first before starting the operating system. These days, we tend to use virtualization for many different uses, and there is hardware inside of your computer that can enhance the overall process of virtualization. This is enabled and disabled inside of the BIOS of your system. Most of this virtualization hardware is built into the CPU inside of your computer, so you'll need to check the manufacturer's specification to see what options might be available for your particular central processing unit. By enabling these virtualization capabilities in hardware, we can make the process more stable and much faster. If you're using an Intel CPU on your motherboard, you want to look to see if you can enable the Intel Virtualization Technology, or VT. If this is an AMD motherboard, then you'll want to enable AMD Virtualization, or AMD-V. In our BIOS, we'll find all of those virtualization options under the Advanced option, and we'll choose the CPU Setup feature. And the first option at the top is AMD Secure Virtual Machine, and we can enable or disable that from inside of our UE5 BIOS. A lot of what we do in technology has to do with secrets. We have a lot of information that we want to keep secret from other people, and in some cases, we want to be sure that the information we're storing on our own system is only available to us and no one else. To provide this security, we need to use encryption, and we use encryption on almost everything. Your mobile phone is using encryption not only to store information, but to transmit information over the airwaves. When we send information back and forth to a web server, that entire network communication is encrypted. And when we're storing information on our local hard drive or SSD, all of that data can also be encrypted. Very often, the process that we use for encrypting and decrypting data is a very well-known process. These are usually based on standards that are open and public, and you can reference and read through those standards to understand exactly what's happening when information is encrypted and decrypted. This is very common to the doorknobs that we use connected to our house. But just knowing how a lock in a doorknob works doesn't somehow allow you access through that door. To be able to gain access, you need the one thing that is unique that no one else has, and that's your key. Although we don't have a physical door key on our computer, we have digital keys that we use during this encryption and decryption process. And if we are encrypting data with a key, we need to be sure that we have the correct key to be able to decrypt that information later. But now we have a problem where we have data that we've encrypted. We need to protect the key that we've encrypted it with. But how do you protect the key that you're using for all of these cryptographic functions? On your personal computer, one of the ways that we can help protect this key is by using a Trusted Platform Module, or a TPM. This TPM is a standardized piece of hardware that is built for encryption. There are many different cryptographic functions built into this piece of hardware. And in this image, you can see that the TPM is a module that was installed onto the motherboard separately. Your motherboard may have the TPM built into the motherboard itself. This TPM includes a cryptographic processor, so we can have random number generation occur on this TPM. We can also generate cryptographic keys on this TPM. This TPM also includes persistent memory, which contains burned-in keys that were created during the manufacture of the TPM. There's also part of the TPM that handles versatile memory, so it can store keys and other information within the memory of the TPM. And perhaps most importantly, the TPM is built for security. This is password protected and has a number of security features that prevent somebody from gaining access to your very private cryptographic keys. This Trusted Platform Module has a cryptographic key that is secret to only your system, and it's unique to only your system. Nobody else has the same key. For that reason, your encryption keys are now associated with your individual computer, and we can use those keys to perform different functions. For example, if you've enabled BitLocker or some other type of full disk encryption on your computer, you can use these keys to be able to provide the encryption necessary to protect the data that you're storing on that device. This also means that you can't take the storage device out of your computer and then move it to another computer to gain access to the data. You would still need to decrypt the data, and the decryption key is back on the original computer inside of the TPM. Since this TPM contains this unique key and it's tied to this piece of hardware, we can associate the hardware with the TPM. We refer to this as a root of trust. We know that that TPM is unique to that system, and for that reason, we can use the TPM to make sure that the computer that we're referencing across the network really is the device that we're expecting. This TPM can also be used to remotely determine if anything has changed with that computer. That way you know if you're connecting to a system across the network, that that system really is the one that you're expecting to find. And since the TPM is physically part of the hardware of the system, it's not something that can easily be copied off and moved to another computer. You know that when you're looking at that TPM, that you really are looking at that particular physical computer. The BIOS of your computer allows you to enable or disable different features of your TPM. On this BIOS, you'll find it under Security, and under Security, if we scroll down, you'll see an option for TCG. This stands for Trusted Computing Group, which is the organization that manages the standards for TPM. On this computer, you see that we have a TPM Security Chip 2.0, and you're able to enable or disable the TPM functionality from inside the BIOS. You can also clear any data that may be stored in the TPM from this setting, and you can configure different parameters on how that information is deleted. Well, the TPM is a good choice for managing security on a single device. But in many of our data centers, we might have hundreds or thousands of devices, and every single one of those devices has some type of security key associated with it. In these types of environments, we need some type of large-scale security solution to manage and maintain these keys. And that solution is a Hardware Security Module, or HSM. HSMs are often used to centralize the backup of all of these keys across all of your systems. So if you wanted to have all of your web server keys stored on one central protected device, you would install an HSM and have that device manage all of those keys. There are also lightweight or personal HSMs that you could use to store personal keys on a device that could then be moved from one computer to another. This is a type of lightweight HSM used for protecting cryptocurrency, where you can store this information and protect it on this mobile HSM. In a data center, however, we're usually configuring a high-end server and configuring it with cryptographic hardware to serve as our HSM. In many cases, this device is not only storing keys, but it's also accelerating the cryptographic functions between one device and another. So for example, instead of your web server performing any type of cryptographic encryption and decryption, you can have that entire process take place in hardware on an HSM and offload that from any of your software-based services. So if we had to compare a TPM with an HSM, we could say that a Trusted Platform Module is generally used on a single system. You're securing data on that local device. It's often built into the motherboard, or you could install it as a separate physical module. And if you are working with a mobile phone that's booting, there's a screen lock process, or there's some type of full disk encryption, you're probably using a TPM. HSMs, or hardware security modules, tend to be used by many systems, and we're usually storing information across multiple devices onto that secure storage of the HSM. These are often deployed in a data center as a high-end device, usually with cryptographic hardware, and they're usually deployed to protect those important keys that you have in your infrastructure, such as the keys you might have to protect the encryption of your web servers or those for your certificate authority.
What's up, affiliate marketers? How you doing? Michael Baschi here. Now, really quick, listen, I know you don't want to be here. I know you.
If you look at the system information for your computer, you'll see a lot of interesting information. For example, on this computer, the system type is a 64-bit operating system, and it is an ARM-based processor. And you may be wondering, what do those specifications refer to? Well, let's start with the 64-bit operating system. In today's modern world, we tend to see two different kinds of operating systems, a 32-bit and a 64-bit. This is referring to the capabilities of the CPU on your computer and how much information it is able to process at any particular time. It also refers to the total amount of address space that a single CPU could reference. For example, a 32-bit processor can store ones and zeros to a maximum of 2 to the 32nd power. And that is a lot of information that we are storing into the memory of a system. But with today's technologies, a 32-bit address size is relatively small. That's why we created a 64-bit processor, which can store 2 to the 64th power of total information. And you can see that very large value is listed on the screen. If we want to put this in a bit more of accessible terms, you can specify a 32-bit processor can reference 4 gigabytes of memory, where a 64-bit processor can reference 17 billion gigabytes of memory. Now, obviously, the 64-bit operating system that I'm using on my computer probably can't reference 17 billion gigabytes, and my computer probably couldn't support that much memory inside of a system. But many operating systems can scale up to very large amounts, and they're able to do that because they're running a 64-bit processor. As you can imagine, there are a number of differences in operation between a 32-bit operating system and a 64-bit operating system. For example, if you're running a 64-bit OS, your hardware drivers that you're using on that operating system need to be written for a 64-bit operating system. If you're using a 32-bit operating system, then you need to make sure your hardware drivers are written for a 32-bit OS. In the world of Intel processors, you'll often see the 32-bit processors referenced as an x86 processor. That's a reference back to the older 8086 style CPU. And you'll see 64-bit processors referenced as x64. The applications that run on these different operating systems are also different. For example, a 32-bit operating system cannot run applications that were made for a 64-bit operating system. The reverse, however, is usually true. A 64-bit operating system usually can run 32-bit applications. If you were to look at your Windows operating system, you'll notice that the Program Files folder has different areas depending on the type of applications that you're installing. For example, all of your 32-bit applications are being installed in Program Files x86, and your 64-bit applications are simply stored in Program Files. There's another CPU architecture that has become very popular in our modern world, and it's an architecture created by ARM Limited. This architecture is named Advanced RISC Machine, which is also abbreviated with the word ARM. This is the company that creates the specification for the chip, and they license that specification to third parties. ARM processors tend to be very, very efficient. They use less power, less heat, and they're very fast at processing information. This is why we see that 99% of the mobile phones that we are using these days have ARM processors, and we're starting to see more and more desktop and laptop computers use ARM as the primary processor inside of their devices as well. We often refer to these processors from Intel and AMD and ARM as CPUs, individual single devices. But inside of that single CPU package are a number of individual processors referred to as processor cores. You'll often see a processor referred to by the number of cores inside of that processor. It might be an 8-core or 16-core processor. And inside of each one of these cores, you will often find an individual CPU and cache memory that is specific to that core. This means multiple cores can perform multiple instructions simultaneously, thereby increasing the overall efficiency of that computing process. If you were to look at a magnified view of a CPU die, you can almost make out the individual cores. This is a rendering of what appears to be a 16-core CPU. You can almost make out the individual CPUs for each core inside of this chip, and you can see where the cache memory is located for each of the cores inside of this CPU.
5 reasons Connect Team is the smartest replacement for workplace.
Connect Team is more than just a feed and chat. It's a full suite.
Our modern computers are designed to be modular. We have ways to extend the functionality of our computer by adding additional hardware onto the motherboard itself. We're able to do this through the use of expansion cards. These are cards that provide additional functionality that's not already available on the motherboard itself. So we can get a generic motherboard and then customize it to do exactly what we need it to do. We've designed these expansion cards to be installable by the end user, so you don't have to take your computer back to the manufacturer to have these installed. You can open up the top of your computer and install the cards yourself. And the process is relatively simple. You can install the hardware in your computer, turn it on, and most of the time your operating system will automatically identify the card, install the proper device drivers that you need, and you're immediately able to use your new hardware. A good example of an expansion card you might add to your system is one for audio. This is a sound card, and it can provide audio output that is far superior to what you might have on your motherboard. This might include specialized hardware to give you higher quality audio, or it may have additional output functions so that you can plug in a home theater with multiple speakers and a subwoofer. These audio cards might also provide input, so you might want to plug in multiple audio sources from different devices. You might have musical instruments you'd like to plug in, or there may be multiple microphones. Here's a sound card that supports a number of different inputs, outputs, and formats. We have audio output on left and right channels, a headphone input, a line input, and then a digital audio output. The CPUs of many motherboards support an integrated graphics function that is built into the CPU itself. But if you're doing some type of high-end graphics processing, video editing, or gaming, you may want a discrete graphics adapter. This is a graphics processing unit that is external to your central processing unit. This separate graphics card provides additional CPU power and memory so that you can perform the highest-end graphics functions on your system. The connectors associated with the integrated graphics inside of a CPU can often be found directly connected to the motherboard. We can see some of those here. There's a VGA, DVI, and an HDMI interface, and they are all connected directly to this motherboard. A separate discrete graphics card, or GPU, has a connection that fits directly in the motherboard, and it has its own video output on the card itself. A discrete graphics card is usually designed for outputting video and memory to your central processor to perform the highest-end graphics functions on your system. The connectors associated with the integrated graphics inside of a CPU can often be found directly connected to the motherboard. We can see some of those here. There's a VGA, DVI, and an HDMI interface, and they are all connected directly to this motherboard. A separate discrete graphics card, or GPU, has a connection that fits directly in the motherboard, and it has its own video output on the card itself. A discrete graphics card is usually designed for outputting video, but often you might want to have video input into your computer, and you can do that using a capture card. This might come from a separate video source, such as a camera, or you may be connecting separate computers as video input into your computer. When you're dealing with video, there is a lot of data that is being transferred. So most of these capture cards will have very high throughputs, and they're usually connected directly to the PCI Express bus. Here's an example of a video capture card. This one supports video input over HDMI and SDI, which is a serialized form of video input, and it connects directly to the PCI Express bus. Although we'll often connect the networks wirelessly, there may be an occasion where you want to physically connect to a wired Ethernet connection. And some motherboards may not have an Ethernet jack built into the motherboard itself. Or perhaps the Ethernet connection on your motherboard is no longer operating. If either of those happens to be the case, you may want to install a separate network interface card. You might also want to install one of these NICs if you're installing a server, some type of security device, or anything else that needs multiple Ethernet connections. And of course, the process for installing a network interface card is exactly the same as any other adapter card. Once you find an open slot on your motherboard, you can install the card and then restart your system and install the proper hardware drivers. If you're installing into a server, you might need a card that supports multiple Ethernet connections, and you can do that by installing a multi-port Ethernet card. This multi-port card supports 4 separate Ethernet connections in one slot of your motherboard. When you're trying to find the right adapter card, you may want to check a number of different sources to find the one that's right for you. For example, you might want to start with your motherboard documentation to confirm that you have the right number and type of interfaces. Then you'll want to check with the manufacturer of the adapter card to see what the minimum hardware and software requirements are to use that particular hardware. You might also want to look into the knowledge base from the manufacturer to see if there might be things that you haven't thought of yet. And of course, you could ask others who are using this adapter what they've seen with this hardware. Some hardware requires you to install a driver before you install the hardware, and other adapter cards require you install the driver after you install the hardware. Make sure you check the documentation for your adapter card to see what the proper process is for that hardware. In many cases, you'll find that the device driver is installed automatically once you install the hardware, but you'll want to confirm that with the documentation prior to starting up your system. You then might want to check the manufacturer's website and make sure that you're using the latest version of device drivers. If you're using a previous version, you may need to manually uninstall that device driver before installing the newer version. Sometimes this is done through the Windows front end, and other times the manufacturer has their own process for installing the device driver. You can use Windows Device Manager to both install the driver and check the status of the driver once the system is booted. You'll then be able to see the device driver details and see if the driver is working properly with your new hardware.
Explaining complex topics can be challenging. Highlight the text you want to simplify and let Grammarly rewrite it. Grammarly makes your message clear so it's understood.
All of the technology inside of our computers creates heat. One of the best ways to cool off the inside is to pull cool air through the system using fans. It's very common to pull cool air into one side of a case, have that cool air pass over the much warmer components inside, which of course heats up the air, and the hot air is expelled out the other side of the case. The layout of devices on the motherboard and the other components inside the case all contribute to how well the air can flow through this particular case. You want to be sure to make sure all of your wires and other components are out of the way and that you have a good airflow to pass from one side of the case to the other. There are many different types of cases, many different types of cooling systems, and all of these work together to provide you with an optimal form of cooling. If you look at the different adapter cards inside of your computer, you may find that the cards themselves have their own fans. This takes the cool air inside of your computer and directs it to a single point on this particular adapter card. It's very likely that the components of this particular kind of adapter card get very warm and need this additional cooling of an onboard fan. Of course, to support this onboard fan, we need enough room, so you may find these fans are only used on larger adapter cards. Very often you'll find these types of fans on high-end video cards or graphics cards. The fans that are installed onto the case of your computer come in very standard sizes, and you'll often find 80mm, 120mm, or 200mm sized fans. These fans are often variable speed, so they'll run at slower speeds while your computer is cool, and then run faster and faster as your computer heats up. This means that as the fans go faster, the noise gets a bit louder, and you can find different types of fans from different manufacturers that have different amounts of audio output. This is important, especially if you're in an environment like I am, where you want to be sure that everything is as quiet as possible. One of the best ways to avoid any fan noise is to avoid the fan completely. To be able to cool these systems, we use a fanless system, or what we call passive cooling. You'll often see passive cooling used in areas where you'd like the system to remain quiet. Things like a video server or a set-top box on top of your television are perfect places to have passive cooling. You often see this type of passive cooling used on purpose-built appliances and devices where the amount of heat can be easily managed. And this is very often used in conjunction with a heat sink to be able to take all of the heat from and spread that heat out over a much larger area. Heat sinks are critical for dissipating heat inside of your computer, and it's very possible you have many different types of heat sink in the system that you're using right now. These work by taking the heat that's on a component and spreading that heat across many individual fins, effectively increasing the surface area for cooling. As the air passes through these fins, it transfers the heat from the fins to the air and begins the cooling process all over again. If you're working inside of a computer that has a heatsink, be very careful about touching them. They get very hot, and it's very easy to burn yourself if the system has been running for any amount of time. You also want to make sure that you have the proper amount of thermal paste so that you have a good thermal connection between the very hot component and the heatsink itself. You might also hear thermal paste referred to as thermal grease or conductive grease. This is an adhesive you put on top of the hot component so that you can fasten the heatsink to the top. This also creates this thermal connection between the hot component and the heatsink. And since you're usually placing the heatsink directly on top of the component, it usually doesn't take much thermal paste to be able to make a good connection. Usually it's a pea-sized component, and that's all you'll need so that it flattens out and distributes itself evenly over the hot component. Another good form to create a thermal connection is to use a thermal pad. This is the pad that you see here that you would put right on top of the hot CPU or the hot component, and you would place a heatsink on top of the thermal pad. You would usually use a thermal pad when you were concerned about thermal paste perhaps leaking out and damaging other components. The thermal pad is not quite as effective as thermal paste, but it still makes a very good connection between the hot part of your computer and the heatsink. And like thermal paste, the thermal pad is not reusable, so if you do remove it, you'll need to replace it with a new one when you put on the new heatsink. These are certainly less messy to install than thermal paste, and you would usually put the heatsink right on top of the thermal pad. And if this is a CPU, we might have a CPU on the bottom, we might have thermal paste or a thermal pad on top of the CPU, we would then put a heatsink on top of the thermal pad or thermal paste, and then on top of that, we might include a fan just to make sure we're getting plenty of cooling all the way down to the component. And if you need a larger fan, you might want to put it sideways. So your CPU is still underneath. You would have a heatsink on top of that CPU, and then a much larger fan that blows air through that entire heatsink. Well, if your fans are making too much noise or they're not providing enough cooling, you might want to consider liquid cooling. This is the same type of cooling you might find in an automobile or in mainframe computers. Usually you would have liquid cooling on high-end systems, but we're finding that liquid cooling is perfect for things like a gaming computer you might have at home. You might also see this liquid cooling used when someone is overclocking their system to try to get as much performance out of their processor as possible. This liquid cooling system usually consists of the heatsink that sits on top of the processor. There are pipes that take the coolant over to a set of radiators that often have fans blowing through them. Once you place that transfer unit for the heat on top of your CPU, you can then have all of the liquid transfer between the CPU itself over to the radiator, have the air blow through to cool off the coolant, and then return the coolant back to the CPU.
CompTIA certification is too expensive? Let me show you some math. A CompTIA certification is going to make up to $15,000 more than somebody who's non-certified. At $15,000,
before we get into this presentation on power, I want to give you a very strong warning to always disconnect from any power source if you're ever going to work on the inside of any computer. Not only is there a concern about electrocution from that direct power source, but there may be components within your computer that are storing power in capacitors. You have to be sure that you know exactly what you're touching inside of that computer, and you have to be knowledgeable enough to know how to discharge those capacitors before you work with that equipment. Another common mistake that I see people make is connecting themselves to the electrical system of the building. You never want to connect yourself or anyone to any part of a building's electrical system, even if it's the ground wire. The ground wire of a building could be energized at any time, so you want to be sure that you do not connect yourself to any part of that system. Our goal when working with this type of equipment that uses electricity is to always have a healthy respect for anything dealing with power. And if you have a system that you're going to be working with, you should always double check and make sure that you have disconnected yourself from the main power source. If you look inside of a desktop computer, you will find a relatively large power supply. This power supply is providing your computer with DC power or direct current. That's because your motherboard and all of the components on your motherboard need DC power to operate. But the type of power that we get from our wall outlet is AC power or alternating current. That's why we need to convert from AC to the DC that your motherboard will use, and this power supply is the device that provides that conversion. These power supplies are designed to convert 120 volts of AC or 240 volts of AC to DC power, specifically separate DC voltages of 3.3 volts, 5 volts, and 12 volts. This is probably one of the most important components in your system because everything inside your computer relies on the power that's being provided by this power supply. You'll see many different terms associated with power inside of a computer. One of those terms is an ampere. You may see this abbreviated as an amp or abbreviated as a capital A. This describes the number of electrons that are moving past a single point in 1 second. Often we'll compare electricity flowing through a wire to water that is flowing through a hose. You can think of amps as that total amount of water flowing through the hose. So if you can increase the size of the diameter of that hose, you can increase the number of amps. Another term you'll see used is voltage. It's often abbreviated as volt or the capital letter V. You can think of this as the pressure of electricity on a particular wire, and in the case of a hose, it would be the pressure of water that's flowing through that hose. If you want to increase the amount of voltage, then you need to increase that pressure, very similar to increasing the amount of water that might pass through a hose. If you know the voltage and you know the number of amps, you can calculate the wattage. This is often described as a watt or a capital W. And we think of this as a measurement of real power use. This is a relatively easy calculation. We simply take the number of volts, we multiply that by the number of amps, and the resulting value is the total number of watts. So if you're working inside the United States with 120 volts and the device is using half of an amp, then the total amount of real power use would be 60 watts. If you look at the details of a power supply, you'll see specifications for AC power and specifications for DC power. As we've mentioned earlier, AC is alternating current, and it is referring to current that is constantly reversing direction. You'll often see this shown as a wave or a curvy line to designate alternating current. So alternating current is what we use to get power from our power plants to the outlets that are in our homes and in our businesses. We often describe this alternating current as the number of volts and how much this is alternating in a single second, and that is referenced in hertz. In the United States and Canada, we have 110 to 120 volts of alternating current. You'll sometimes see this abbreviated as VAC for volts of AC, and that is running at a 60 hertz rate. Hertz is often abbreviated with an HZ. If you're in Europe, you're probably running 220 to 240 volts of alternating current, and it runs at a rate of 50 Hertz. Our alternating current is the input to our power supply, and of course our power supply is outputting direct current, or DC. You'll often see DC shown with the graphic of a single line and multiple lines underneath. Direct current, as the name implies, is power that is moving in a single direction with a constant voltage. So the power source that we're connecting our computers to will be different depending on where you are in the world. As we mentioned, in the US and Canada, we'll see 120 volts of AC running at 60 Hertz, and Europe is 230 volts at 50 Hertz. That means that if we are moving a computer from one place to the other, we need to be sure that we are connecting a power supply that can use the type of input that is used in that country. If you were to look at the back of a relatively old power supply, you might even see a manual switch in the back where you tell the power supply what you're connecting to. And that switch is usually marked with 120 volts and 230 volts. If you're not sure what type of power is coming out of the outlet that you're connecting to, you might want to grab a multimeter and test that outlet to see what type of alternating current is on the other side. If you look at the back of your computer, you might notice that it doesn't have a switch to manually move between 120 volts and 230 volts. That's because most modern power supplies will recognize the type of power they're connecting to and will adjust accordingly to work properly regardless of where you happen to be in the world. If you do have one of these manual power supplies, you want to be very careful of how you're configuring that switch on the back. You don't want to take a power supply that is currently set for 120 volts and plug it into a 230 volt power source. If you plug in a power supply with those settings, then you'll probably quickly find the power supply will be overloaded and it will most likely be a spectacular failure. Here's a better view of this manual switch on the back of one of these older power supplies. If you are planning to connect this device for the first time, you may want to reference that settings to see what it's configured for on that power supply and make any change that you need before connecting it to the power source. Once the system is configured to the proper voltage and it's connected to the power source, you can leave that switch exactly where it is. So now that we've talked about the input to the power supply, let's talk a little bit about the output from the power supply. That is going to provide us with a number of different voltages in DC or direct current. You often see these DC values referenced as a positive value and a negative value. In reality, it's referring to the difference in potential based on where you happen to be. You can think of this as measuring the heights of your home from your front door. If you wanted to measure the second floor of your house, it would be approximately positive 10 feet above you. And if you were measuring the basement, it would be negative 10 feet. Both of those are 10 feet away, but obviously the distance is relative to where you happen to be standing. If you look at your power supply documentation, you'll see there are a number of different outputs that are available from the back of that power supply. One of those is probably a positive 12 volt. This is for PCI Express adapters, hard drives that you might install into a system, or anything else that needs that much voltage to be able to operate. You may find some motherboards that use plus 5 volts for components that are on the motherboard itself, although many of our newer motherboards tend to use plus 3.3 volts. That 3.3 volt power is primarily used for the motherboard to power up the M.2 slots, the RAM that's on your system, and the other assorted components on the motherboard. And you might also find that your power supply provides plus 5 volts of SV power. This is the power provided to the motherboard when it's in a standby or sleeping state so that we can wake it up using signals across the network or by pushing a button on the front of the case. You may find some motherboards using negative 12 volt of DC power. This is often used for integrated local area network connections on the motherboard, and there may be some older PCI cards that use the negative 12 volts. And for older power supplies that are providing power for legacy motherboards, you might see them providing a negative 5 volts. This is for an older style of adapter card that's no longer used, and you may find that your power supply doesn't even provide an output for negative 5 volts. If you're not sure the type of output and how many amps are supported for each of these voltages, all of this is documented in your power supplies manual. You might also see those values right on the side of your power supply for easy reference. To get power to our motherboard, we have a main power connection that is a 24-pin connector on the motherboard itself, and it provides the motherboard with 3.3 volts, 5 volts, and 12 volts of DC power. This was originally a 20-pin connector, but most modern motherboards are using the full-size 24-pin connector to connect the power supply to the motherboard.
Should I switch to Monday CRM?
Updating this field is so confusing. This CRM sucks.
If you do run into one of these older motherboards that only has a 20-pin connector on the motherboard, you can still use the 24-pin power connector from the power supply and simply not use those last 4 pins that are on the connector. Here's a 24-pin connector you'll find on a motherboard, and it is probably one of the larger connectors that you'll find on the motherboard itself. To be able to connect the power from the power supply, we simply take the 24-pin connector that is coming from the power supply and place it into those slots on the motherboard. This can only fit into this connector one way because this entire connection is keyed, which prevents us from plugging it in with the wrong orientation. If you're working with servers and other infrastructure devices, you may find that there are multiple power supplies on the back of the unit. These are designed to be redundant. Each power supply is designed to support the full 100% power required by the system, so if you lose one of those power supplies, the other power supply can continue to keep that system up and running. Very commonly, these two power supplies will run at 50% of the load, and if you lose one of those power supplies or it comes disconnected from the power source, the other power supply will take 100% of that load. These are also designed to be hot swappable. You can see there's a switch on top of this motherboard that allows you to slide it out of the chassis even when the system is up and running. This means that you can maintain 100% uptime, but be able to replace any of these power supplies if you run into a problem. Many less expensive power supplies will have fixed connections coming out of the power supply itself. This means we'll have a large grouping of cables that will be sitting inside of our computer case, whether we're plugging a device into those connections or not. Higher-end power supplies tend to be more modular, where you can simply connect only the cables that you need to use inside of that particular system. And if you need to add more later, you can simply plug them into that modular connection. And if you need to remove a device from your computer, you can remove those cables from the inside of your case. Here's a hybrid power supply that has some fixed connectors, but it also has modular connectors that you can plug in if you need them. Here's a power supply that is completely modular. You can see that they provide all of the cables that you would need to connect, and you can simply plug in the cables that you need to provide power for your specific requirements. If you're purchasing a power supply, you'll notice there are different models that will support a different number of watts. Generally, if you're getting a power supply that supports a higher wattage, that power supply tends to be more expensive. You can certainly spend the extra money to buy a power supply that gives you much more capacity than you'll ever need, but that doesn't provide you with any additional speed benefit for your computer. Even though different power supplies may support different wattages, the physical size of the power supply doesn't tend to change. So if you're upgrading a power supply inside of a computer case, you might upgrade to a higher wattage, but the size of the power supply itself will be exactly the same inside of that case. If you're trying to decide just how many watts you need in a power supply, then you'll need to calculate all of the different components inside of your computer and add up what the maximum number of watts might be required for all of those systems to work together. So you'll want to check your documentation to see what the CPU requires for wattage, what your storage devices will need, what your video adapter requires, and then any other components inside of that system. If you have a separate video card inside of your computer, these usually require a significant amount of power, and you'll want to check the documentation for that video card to see what the requirements are for power inside of that computer. A good rule of thumb is to get a power supply that can support 50% of your total load today. That means that the power supply will not be overloaded, and you'll have plenty of room for growth in the future. Another useful specification when you're looking to purchase a power supply is the energy efficiency. When we're converting from alternating current to direct current, we lose a bit of power each time we make that conversion. That lost power is converted to heat, which of course creates more of a cooling issue for the computer that you're using. If you're concerned about this efficiency rating, you may want to check the different values associated with those power supplies. The standards tend to be somewhere between 80 to 96% efficiency, depending on the quality of the power supply that you're purchasing. If you get a power supply that's more efficient, then you'll have less power that is lost during that conversion process. And because you're losing less power, you have a lot less heat in your system, and overall, you're saving money not only in powering the computer, but keeping that computer cool. There's a certification program that power supplies can go through to determine their efficiency. You'll see power supplies rated as an 80 plus, an 80 plus bronze, silver, gold, platinum, or titanium. This means that the 80 plus with no rating would be the least efficient, and an 80 plus titanium would be the most efficient.